This conference will now be recorded.
Hello, can everybody hear me? This is Brian.
Morning, Brian. I can hear you fine.
All right, excellent. I'm about to start sharing my screen.
Beautiful.
All right, perfect. All right, I think we're ready to do it.
Good morning.
Good morning. Who's just joined?
Michelle.
Welcome, Michelle. I think when this starts, I'm going to probably put everybody on mute, and then we'll be using a chat function if you have questions or anything, just to kind of make it a little bit easier.
We're gonna give it a couple more minutes, Brian, and see if we get some more people show up.
Perfect. Yeah, no problem.
Hello.
Hello.
Yes, good morning.
Welcome.
Good morning. Nick Pappas here.
Nick, good morning.
I think we'll be getting started in just a couple minutes. We're just waiting for a few more people to arrive.
Okay, I think we're ready to start. I'm Brian, and then if other people join in, we may have to go over a couple of things, but let's go ahead and get started this morning. I'd like to welcome everyone to J.A. Moody's AEV Cryogenic Ball Valve Product Seminar. If you're not familiar with J.A. Moody, we are a valve added distributor of flow control products to the marine and commercial market in the U.S. And if we have sales and service facilities throughout the United States, and you can visit us at the www.jamoody.com to see some of the other products we carry and to meet our sales force and get their email addresses and phone numbers if you'd like to contact them in the future. This morning, Bryan Hodges is going to be the presenter for this webinar. Bryan is the AEV Valve Business Development Manager for the industrial and marine markets in North America. Prior to Emerson's acquisition of AE Valves in December of 2018, he was the North American sales manager and has been with AEV for 5 years. Before coming to AEV, he was an independent rep selling the valve in North Texas and Oklahoma. He has extensive knowledge of AEV's product line and experience throughout the US and Canada, having developed much of the existing install base of this valve. Before entering the valve and automation business in 2006, Bryan graduated from engineering college at Texas A&M University. He is married with 2 children and lives outside of Dallas, Texas. Bryan, it's yours. Thank you for being here this morning.
Thanks, Rick. I appreciate everybody joining us. And I'm going to kind of make the assumption, just as we start this presentation, that I'm introducing AEV and our valve to everyone for the first time. So if you've seen it before, please have a little bit of patience. We're going to kind of go through some of the basics, but also I think there'll be plenty of new stuff for everybody to pick up on and discuss as we go through this presentation. And as Rick stated, AEV is part of the Emerson isolation valve brand. We were acquired by Emerson in December 2018. But before that, we've been around about 10 years. But actually, the valve, we started AEV in 2009. And so that being said, we have a lot of experience. We've grown exponentially. We have a large install base, but in reality, when it comes to the valve world and the valve industry, we're still kind of the fairly new players on the block, and so we're introducing the valve to new people every day. And really, we've really turned that into an advantage because we have a lot of things that separate us from the rest of the isolation valves out there, especially in cryogenics. And the main things that do that is it pretty much comes down to that there hasn't been a lot of innovation or new technology in the valve industry. The newest technology out there is a triple offset butterfly valve, and that was developed in the late 1950s, early 1960s. And so what we did as a company, and as we recognized this kind of gap in offerings and technology in the isolation valve industry, is what we did is we designed the ball valve from the ground up, and we redesigned it, and we got to do it using today's technology, things like 3D CAD modeling. We got to run finite analysis on the valve before we ever made our first valve and see how it performed in different services. And then also we got to take into account things like some modern manufacturing processes like 5-axis machining and higher quality casting controls and procedures. And so we really have something that we feel like is a lot different, brings a lot of value to both the asset owners and also the ones engineering and designing these systems. And so as we go through, you'll see that it's really something different, something fun to talk about. It's very difficult to explain via email or phone, so that's why we like to do these kind of presentations. And if you guys have questions as we go through, just use the chat function, and I'll be paying attention to that, and I'll try to answer anything that comes up, and make sure that that we're able to keep this thing moving. But I don't mind going off on a tangent and explaining things. That I think if you have a question, probably other people in the presentation here have the same question, so don't be shy. So when we were designing this valve, these are the 4 key values that we really wanted to take into account and really build the valve around. And as we go through and I show you the valve, you'll see these 4 themes come up again and again. And the big one is we wanted to have a safer cryogenic ball valve. And we did that by making a cryogenic ball valve that's cavity free. There's no trapped cavities, no ball cavity, no body cavity. And this is where you get into a lot of issues when you're dealing with cryogenics and something going through a phase change, starting from a gas to a liquid. We wanted to make a valve that was more reliable. Many of these valves end up in emergency shutdown situations or safety integrity situations, or also they're manual valves that don't get used very often. But when they do get called upon, it's because there's a maintenance issue. Maybe someone has to open pipe, something like that. We want to make sure that this valve is going to work and work every time. The other thing we did is we wanted to focus on simplifying piping, and we did that by making our valve bi-directional. So now what we have, kind of, we go back to that safer bullet points, we have a valve that's bi-directional. It has no trapped cavities. This means no venting or anything like that. And so really what it does is it eliminates a lot of issues when it comes to install and design, or maybe valves can get installed backwards, or operators have issues understanding which way a valve's installed or how it functions. And then the last thing is less waste. We have a valve that seals tighter than anything else on the market. And then also we took into account today's emissions issues and standards, things like that, and try to make the most efficient valve possible. So a little bit about AEV. We're based out of Belgium. At the moment, all of our valves are manufactured in Belgium. We have a state-of-the-art manufacturing facility there that we built about 6-7 years ago. When we originally built that, actually just as we completed it, we were growing so fast we doubled it in size. And now we're doubling it again in size. We purchased the property right next to us, and we're building a whole other building, kind of a mirror image of what we currently have, and it should actually be completed here this summer. So it's kind of nice. We have a modern, clean, super efficient manufacturing facility. And so not only do we consider ourselves technical leaders in design, but also in manufacturing and project execution. And then this is what we make. It's all the same basic design. What we make is a top entry trunnion mounted ball valve. We make it 1/2 inch all the way up to 42 inch, class 150 all the way up to class 4500. We make it both in soft and metal seats. It's fire safe to ISO 10497, which encompasses API 607. It's certified low emission. It's TUV certified for SIL 3. We do a lot of stuff in like HIPS applications. And then also we've been active in the marine market. So we have multiple ship classifications, which includes stuff like ABS, DNV, and quite a few others. And we'll get into that a little bit here in a second. But one thing before we leave the slide, what I want to point out is this third bullet point from the bottom, where it says design standards. Although our valve is a little bit different, looks a little bit different, it's a ball valve and it's built to ball valve standards. So it's built to ANSI B1634, has an ANSI B1610 face-to-face. It's built to both API 608 and API 6D. And I think as we discussed earlier, like it's fire safe to API 607. And so what we're trying to get at here is whatever your piping standard is, this valve, and if it's designed to have ball valve isolation in it, our valve should drop in place without having to make any exceptions to use it. It should adhere to your spec, and it should be fine and good to go. Let's go back one. Here we go. So some of our ship classifications and experience that we have in the marine industry, we've been very active in a lot of this floating LNG boom. We did both Golar ships through Black and Beach. We recently did the Any Coral FLNG ship through Technip in France. And then also, as we see these the bunkering become larger, we've been active on that with the LNG bunkering barge going to Jacksonville. And then we also do some stuff on the FSRUs through Accelerate and other places throughout the world. So we've been very active not only on the design side and some of the processes here in the U.S., but also the shipyards in Korea and Singapore and other parts of the world. And then also some of the OEMs in Europe, where we're seeing these fueling systems for these dual fuel engines be designed and manufactured and shipped out to these shipyards and engine manufacturers, people like Wärtsilä and MAN. So we have a lot of experience out there, and we've been able to kind of gain this experience and gain this install base because we feel like we bring a lot of value, not only to, like I said, not only to the end user, but also on the engineering side, and it makes it a lot easier. But here's some of the places our valves installed, some of our customers. Like I said, Black & Veatch has been very active in the FLNG with their Preco process and making LNG on large ships for Golar. Accelerate is a large leaser of FSRUs around the world, and as they bring those boats in for their scheduled maintenance and upgrades, they've been very active on switching out some of their old valve technologies for AEV. QLNG, the LNG kind of bunker barge, we did a lot on that through VT Halter for Harvey Gulf. Harvey Gulf also has an on-land bunkering system down in Port Fourchon that we provided all the cryogenic ball valves for. We've also been to like the Shell design verification test, and then we've also been very active outside of marine on all the large LNG liquefaction facilities being built in North America, as well as the regasification stuff over in Asia and other parts of the world. So I would say, kind of come back to the opening statement, like we're fairly young when it comes to comparing us to our competitors on the market, but in that short time span, we've probably become number 1 or 2 worldwide in market share, and our install base is massively growing, and we're probably number 2 installed worldwide for cryogenic ball valves already. So here's the fun stuff. This is how our valve works. And how it works is basically it's a trunnion ball valve, and the trunnions are offset somewhat similar to like a high performance butterfly valve. And so then what we have is a ball that cams into a fixed seat. And this is really what makes us different, because now what happens is all sealing comes from torque applied to our stem. And so we feel totally independent of process pressure. Every other cryogenic ball valve out there is using process pressure to help assist in its sealing. But we're going to seal the exact same independent of process pressure, meaning we seal just as tight at 1 psi pressure differential or 1,000 psi pressure differential. And also, because it's a camming motion with the offset trunnions, it means it's low wear, the ball comes away from the seat. Another thing we've done is we've eliminated all kinds of springs or dynamic seals, right? We now have a fixed ball on trunnions and a fixed seat. And this allows us to maintain tight shutoff through thermal cycles, through pipe stresses, and a lot of other things where traditional cryogenic ball valves have always struggled. And here's a neat video showing in reality how it works. If you look at this, you can see how there's no rubbing between the ball and the seat. And you can see how the ball cams into the fixed seat and stops rotating. And then when it opens back up, you can see the ball gets totally out of the flow path. There's no interrupted flow. We make this valve in a full bore and with like a standard reduced bore, and so you get the same CVs as you do out of traditional ball valves. And so there's a couple of neat things happening here. Really, like when we put this together, what I was trying to show and I wanted to kind of pass along to people was that is show the offset of the trunnions. And so they have these 2 axes here. There's an orange axis and a red axis. The orange axis is the center line of the pipe and the valve. The red axis is the center line of the ball and the trunnion. So if you look down at the bottom, let's see if I can get a little laser pointer action here. Here we go. So we look right down here, you can see how it's rotating off a point off center. And that creates this camming motion where the ball presses into the seat and creates a tight seal. And so this operates on something actually called a logarithmic cam. And what it does is it gives us a bit of a mechanical advantage, almost like a lever arm gives you a mechanical advantage on kind of torque applied to the stem versus the force the ball presses into the seat. And so there's actually this forward lateral motion, and this ball presses into the seat and creates a tight seal. And all of that's based off this, where we put the offsets and how much of an offset there is to give us this mechanical advantage. And this was really difficult for us to figure out. This is a big part of our technology. There's a couple other neat things about this valve is the seat is not indexed. It's just a normal round seat. You know, technology like this has been around for quite a while in control valves. We see it in things called like eccentric plug valves, segmented balls, V-balls. But the big difference between us and these other technologies is that we're designed for isolation. We're designed for tight shutoff, while those valves are designed for control. All of those valves typically have a spring in the seat. A lot of them, their seats are also they're not round. They have to be placed just perfectly for the ball to come into them. Where us is like we're designed for tight shutoff. We have a normal round seat, and what this does is it simplifies everything. We have a fixed seat that can be replaced in line. It gives you a repeatable tight shutoff, and then it seals totally independent of process pressure. So really, that's the big difference. We can get zero measurable leakage. It's built to ball valve standards, and it's designed for isolation. So inversely, we're going to talk a little bit about how traditional ball valves work. And the reason I like to go over this is because I don't think that a lot of people have given traditional ball valves a lot of thought. They're very simple items that, you know, you turn them 90 degrees, they turn things off. That's really kind of the most thought most people give them. But in reality, they are simple items, but there's a little more to how they function. And understanding how they function really will explain where their issues come in when you try to apply them to cryogenics. And talking about how, at that opening statement, how there wasn't any new technology in this industry, I'm kind of going to run through that a little bit here. This is a standard floating ball valve. This is pretty much all floating ball valves are going to be the same basic design, even cryogenic ball valves. And they all use the same design. They all have like some different workarounds for different applications, whether it ends up being severe service or cryogenics or anywhere in between. But how they work is that you have a ball valve here, and the ball is just floating around in a body cavity. And so this is your high pressure side over here, and you're using this pressure to help push this ball into this downstream seat. And this is where all your sealing comes from. You need a certain amount of differential pressure to push this ball into the seat, create a tight seal, and it works pretty well. Where the issues come in with this, especially in cryogenics, is that you have this unfixed ball, and it's going to go through thermal cycles, expand and contract at different rates compared to the body. Then also you have basically like you have a huge variable in the amount of force that is applied to this ball and presses it into this downstream seat. And so if you close this valve at full differential pressure, it will seal tight. It'll push that ball into the downstream seat and seal tight. But then if you close it at a low pressure differential after, there usually is not enough force to move that ball back in that same position into that seat and create a tight seal. And so in fact, like when you do a cryogenic test, they're all based off the same basic test, which is the British standard, the BS 6364 test. And there's a low pressure and a high pressure test. Well, no manufacturer will do the high pressure test first because they know they do the high pressure test, they'll deform that downstream seat and they won't be able to seal at a low pressure. And the other issue with these valves is also if you have a very low pressure differential, and say this becomes a larger valve, a 4, 6, 8-inch ball valve, you probably will not have enough force to push this ball into the right position in the downstream seat and get a tight seal. So it basically becomes a big, heavy mass object like a cannonball in there. You got to have enough force to really push it into that downstream seat and create a seal. Inversely, this is your traditional trunnion ball valve. Just like the floating ball valve, they're all the same basic design. You have a ball that's now fixed on these trunnions, so it operates in a concentric motion, and since the ball is fixed, we have to have some floating seats now. And so you have these floating seats that have these springs that engage the seat to the ball, but this is not where your sealing comes from. Your sealing comes from this purposeful gap behind the seat where your process pressure is designed to penetrate, get in there, and help push this seat into the ball. So if this is the same as the previous slide, with this being the high pressure side of the valve, instead of sealing on the downstream seat like a floating ball valve, we're now going to seal on the upstream seat. And really where the issues come in with trunnion ball valves is this mechanism here, right? You have a lot of different materials here. You have to have a floating seat. It has to be able to float freely to create a tight seal. And where the issue comes is this right here. Because this seat is floating, there has to be a dynamic seal between the body and the seat. And now what we have here is a lot of different masses and a lot of different materials that all expand and contract at different rates as this goes through a thermal cycle. And so the typical rule of thumb is that soft goods expand and contract 10 times faster than metal. So now we have a soft seat and a soft dynamic seal here between the body and the seat. And so as the media hits this and cools it, you're going to have this small seat, which is a much easier mass to cool down than the ball and the body, contract much quicker. You're going to have these soft goods contract much quicker. And really where you get your leakage on the trunnion ball valves is back here behind the seat. But you're going to be having pressure help push this into the ball. So you'll maintain your seal at the seat insert and the ball, but it's between the seat and the body that you get your leakage. And this becomes very difficult to control because you never will get the body as cold as the process. And I mean, no matter how much insulation and other things you put on it, the seat will always be colder, and it becomes very difficult to seal this, especially as during a cool down or a warm up of a plant or a system. And so this is the solution. This is what a purpose-built cryogenic ball valve company uses. They use like a pressure energized lip seal, something like this, to help battle that expansion and contraction between the seat and the body. And I had our engineering team put this drawing together for me so I could use it as a visual in presentations like this. And I remember when I got it, I talked to them. I said, "Guys, this can't be right. This can't be how it works." And they assured me that it was correct. Because what I was thinking is, like, we sell a lot of valves into high pressures, right? We sell in class 600, 900, 1500, and all that pressure is being held back by this little Teflon seal here. And really what it's designed to do is the pressure comes, it hits this, it's going to expand it and close out this gap and create a tight seal. But it's a huge weak point when it comes to when you're holding back large pressures and what usually is LNG, which is a volatile or a combustible substance. The other thing that we discussed, and I encourage everyone to look at if you're ever looking at trunnion ball valves in this application, is ask the question: is how is this fire safe? Right, because there's not graphite here, and there's a pretty big trade-off. It's right easy. You can use graphite here and try to achieve a fire safe rating, or you can use a slip seal and try to get a tight seal. But it's hard to do both. And in reality, like this is a neat picture. It was at a trade show over in Barcelona a few years ago for the Gas Tech, and our competitor's booth was down the way a little bit, and they had a cutaway. And I walked by and I took this picture, and I just couldn't believe like how accurate that drawing was. That the lip seal that they were showing me was exactly as described. And so if you look at this, you can see we have a lip seal here holding back all of the pressure for this valve, but also there's a lack of graphite. So I encourage everyone, if you're looking at cryogenic ball valves, trunnion ball valves, and you're using them for emergency shutdown or isolation, you need to question and look at their fire safe certificates versus what you're getting quoted on the bill of materials. Because what's the big difference between us and all these other cryogenic trunnion ball valves is that we have a fixed seat. It's either screwed or bolted into the body, and because it's fixed, we can use a static graphite gasket here. And so what we've done is we've eliminated this leak path behind the seat, and we have a very robust fire safe design using a graphite gasket versus some sort of soft Teflon or other material here as a dynamic seal between the seat and the body. And this is actually our engineered drawing of our seat design versus a very simplified drawing of a trunnion ball valve seat design. So you can see here just kind of how simple it is, how robust it is. It works extremely well. And I think these are some of the main reasons we get such a high seal rating, and we have such a high success when discussing some of these these safety options with customers. So just kind of to compare our valve versus traditional ball valves, it's just we have a much simpler design, a lot fewer parts. We offer this mechanically assured shutoff sealing, totally independent of process pressure, right? We're sealing the exact same at 1 psi pressure differential or 1,000. We're not going to leak through a thermal cycle, and we just have a much simpler, more robust, fire-safe design. So moving on from that, the other big deal when you're talking about cryogenic ball valves is the cavities inside the ball valves. They all have to be addressed, right? Because when you have a media that goes through a phase change, there's a huge amount of volume change when it either flashes from a liquid to a gas or goes from a gas to a liquid. What we're really worried about is going from a liquid to a gas. And so LNG, for an example, goes through a 600 times volume change. So this means if it flashes from gas or from liquid to gas, it's going to expand 600 times. And so with that, you can't have any trapped cavities. You have to be able to vent that to prevent, a bomb from going off, basically. And the way that there's two ways that traditional cryogenic ball valves have done that, and it's usually by either drilling a hole in the body or creating some sort of a body vent. But the key here is that when you do that, it opens up a whole host of safety issues. And the biggest one is that now this valve is unidirectional. So then a lot of assumptions have to be made, right? After this valve is installed, you have to make the assumption that it's installed properly because it's probably covered in insulation. You have to make the assumption that the operator understands how this valve is installed and which way it's sealing, right? And that it's not bidirectional. And you also have to make the assumption that it's going to vent properly when it needs to vent, if it has to vent. And so this is where having a bidirectional valve that's cavity-free like ours makes a huge difference. And when we get into some of these larger systems that we've done, this has really been the savior for some of these construction crews. Because ultimately what we have is we have a valve that is cavity-free and bidirectional, and it's a top entry unibody valve. And so actually the number one way that we sell it is with butt weld ends. And so if you install this valve backwards and it gets covered with insulation and it goes out into service, it's not a big deal. It's still going to seal tighter than our competitors will seal in their unidirection, in our non-preferred direction. So really the way that we describe it is we have a bidirectional valve with a preferred direction. So if you buy any of our valves or install any of our valves, this is going to be the high pressure side behind the ball here. But ultimately, we've done a lot of these large LNG projects where they're installing thousands and thousands of these valves. And usually when that happens, you bring in every welder you can find in site that's qualified, and you have all these contracts, welders out there, and they can be doing their best and thinking they're doing things correctly, but valves get installed backwards. It just happens. And so to have a cryogenic ball valve that's been tested in both directions and verify that's bidirectional, this increases a whole host of safety issues. If you're unable to go back and reverse that valve, you can leave it as is and just check the test reports to make sure it's bidirectional. And then the biggest thing it does as well is on the engineering side is it simplifies the piping design, right? You don't have to worry about venting upstream or downstream, making sure the right valve goes in the right place in the plant, making sure everybody's picking the right tag numbers and placing them in the right place. And so this is a huge safety factor. And this is where a huge amount of value comes in, like I said, not only the asset owner, but on the design and engineering side as well. And then the other big thing, right? Low wear. I think we all saw this in that first original video. We don't make contact with our seat to the last few degrees of rotation. It's low friction. This minimizes a lot of the chances of particles getting stuck between the ball and the seat and cutting the seat. It really enhances the life of the valve when it comes to just reliability and being able to shut off when called upon. And this is what our soft seat looks like. It's a soft seat insert that's fully encapsulated in our seat assembly. We do things quite a bit different here. It's kind of neat, actually. We'll take that soft seat insert during the manufacturing process, and we'll drop it in a bath of liquid nitrogen. It shrinks it, and then we set it into the seat assembly and let it expand. and then after it's done expanding, we crimp it in. It's kind of hard to see here with these colors, but you crimp it in here and here, so it's totally encapsulated. It'll never come out of there. It's fully supported, and what it does is allows us to use this exact design all the way up to class 2500, and you can open and close our valve with full pressure differential across it without damaging anything. It's very robust, it's very reliable, and it's very simple. And so another couple nice things when we're talking about the marine market and our valve is mass. So like I was kind of mentioning earlier, our valve's top entry to unibody design, and the main reason that we go with this, and the main reason this is so popular in cryogenics, has to do with the goal of eliminating connectors, right? Connectors are leak paths or leak points, and when you have these big cryogenic systems, I guess big or small, right, they're going to go through these thermal expansions and contractions, and there'll be pipe stresses happening throughout the system, and usually where those result in is maybe a leak at a connector. So having a top entry unibody valve, eliminating any kind of split body, helps with that, and then making it butt weld even better, right? And so ultimately, though, when you have a top entry valve, it becomes a little bit more mass and becomes a little bit heavier because you have to add this top bonnet flange. Well, with our C-ball design, we were able to decrease the size of our top bonnet flange by 40%. And ultimately what that did is decrease the mass in our valve by 30%. And so when you start getting into putting these things on boats, or you're putting them in situations like this is an LNG loading arm, or other places, it becomes a really nice feature where you can save a lot of mass, save a lot of value, it adds a lot of value, and you get to keep that unibody design. So testing, this is also kind of a fun thing to talk about here, and I mentioned it briefly earlier when we were talking about the thermal expansion and contraction in traditional trunnion ball valve seats. But this is what a cryogenic ball valve test looks like. What you do is you take your valve and you drop it in a bath of liquid nitrogen. You bring it down to cryogenic temperatures, and then you do a low pressure and a high pressure test using helium. And so there's an allowable leakage rate. Helium is a very difficult media to seal with because it's a very small molecule, and then also you got this valve at cryogenic temperatures. It's a very difficult test to pass. But ultimately, in our mind, and what we've decided at AEV is that this test is inherently flawed, and it's inherently flawed in favor of the valve manufacturers, because what's happening here is you're getting this valve perfectly uniformly cold. You're getting the body as cold as possible. And what you're doing is you're shrinking that body and those seals and those seats to the ball. So you're shrinking it from the outside in, where in reality, when this gets installed and used in the real world, you're going to have your cryogenic media going through the valve, and you'll be shrinking it from the inside out. So you'll be pulling the ball and the seals and the seats away from the body. And so what happens is we have a lot of manufacturers that struggle to pass this test, but will pass this bench test and then never seal tight in the field. And this is where, when it comes to talking about like some of the things we're harping on earlier, like that floating ball in a traditional floating ball valve design and these floating seats in a traditional trunnion ball valve design, they really create some issues. Where we have the fixed seat and the fixed ball, we're able to control how they interact with each other and where the ball and the seat are at all times. We won't leak through these thermal cycles. So how the test works, right? You do your low pressure, high pressure test with helium at cryogenic temperatures, and the allowable leakage rate is pretty significant. It's 150 cc's of helium per inch of valve per minute, right? So you do your pressure test, and you're allowed to leak it. You know, if it's a 4-inch valve, you're allowed to leak 600 cc's of helium a minute by that valve and call it a tight shutoff. In reality, AEV test to is 10 times the standard. So we test to 15 cc's of helium per inch of valve per minute. And we usually get way better than that. I mean, we get close to zero measurable leakage. A lot of times we get zero measurable leakage. And then this is very repeatable in the field as well. Just kind of show you what it looks like. This is a third-party, witness test report This is for an LNG facility I mean, this is probably 7 or 8 years ago that this was done, but it's hard to see because it's pretty small. This is a 4-inch Class 600 ball valve. So allowable leakage on this would be 600 cc's of helium. And in our preferred direction, you can see here we got 2. So this is about 300 times better than our competitors can get. In our non-preferred direction, we got 18. That's 3% of the BS 6364 standard. So in our non-preferred direction, we're getting about 30 times better than what our competitors can get in their unidirection. And so you can see here, this is kind of what we're talking about when we're saying we're bidirectional with preferred flow, with a preferred direction. But even in a non-preferred direction, we're getting 30 times better shutoff than our competitors are getting. In reality, this is kind of neat. This is a graph showing that. So what we have here, right, is this is this is BS 6364. It goes up to 150. This is our internal standard, 15. And on that same day that 4-inch valve was tested, these are all the other valves that were tested by that inspector. And you can see here some pretty wide range of sizes and pressure classes. And the results are all pretty much the same. We've got 12-inch 150, a 24-inch 150, 18-inch 600, 14-inch 300. It's kind of all over the map. But the results are the same. And that's because we really have the same basic design, no matter if it's a half-inch valve or that 24-inch valve. And then what this does is it allows us to really get a repeatable process in the manufacturing side and get repeatable results on what we produce. So kind of getting back to that safety value proposition, right? The things that we've done so far to really ensure that we have the safest cryogenic valve out there. We've done everything we can to minimize seat leakage by relying on process pressure to seal, to low wear trim. We've minimized body and connection leakage by having a unibody top entry valve that's welded in place. And then we make sure we have like a reliable valve that's going to operate on demand without any kind of trapped cavity, that is bidirectional, and it's really going to reduce any kind of catastrophic failure due to venting, due to installation error or operation error. So kind of some of the best practices, right? We offer that mechanically assured shutoff, bidirectional, no cavities, low wear, low emission, robust, fire safe design and certification, and then a unibody design. And one thing we haven't really touched on yet, along with that picture I was showing you guys before when we were describing how we have 30% less mass because of our smaller top bonnet flange. Another thing that really reduces the mass and brings a lot of value to everybody with our valve is that when we designed our butt weld valve design. We welded in place without pipe pups and without having to disassemble the valve. And so what you can do with our valves, you can weld it in place without pipe pups, which means we're going to save a lot of space and a lot of weight, again, on top of the original valve design. And then also you're going to save a lot of time and effort. Let's say if you didn't have room for pipe pups, and our competition, what happens is they have to disassemble their valve, remove the seat, weld it in place, put it back together, and then get going. And so this adds a lot of time and cost to startup and construction, but also enters a whole other variable of, is that valve put back together correctly? Right, this valve was already tested as it was, and now we've taken it apart and reassembled it in the field, and you never really get back to those perfect conditions that you had in the manufacturing facility. And so this is a really big cost saver. It's been a really big selling feature for us. You don't have to buy the pups or anything else. It's a really nice feature. And if you have any questions about that, just let us know. We have thousands of these installed in the field without issue. Does anybody have like any questions on this at all? Is everybody understanding kind of what we're talking about here? I know I kind of get my momentum going and I get kind of excited talking about it, but if you guys have any questions or anything, please chime in or use the chat function. I'll be happy to address it for you. Just a quick slide showing how simple the valve is. It's like 13, 14 pieces in the entire valve. I think if you guys have ever seen any other trunnion ball valves disassembled or just an exploded drawing of a trunnion ball valve. You can see just like the hundreds of parts and pieces that go into it. We were really kind of focused on keeping it as simple as possible and eliminating any kind of points of failure when we designed this valve. Kind of a Murphy's Law kind of situation. For SEAL 3 certificate, we really get involved a lot, like I said, in emergency shutdown situations and also with HIPS and some other things. It's very high numbers. We've had a couple situations where we've been able to eliminate partial stroke, where our competitors have had to use partial stroke, and this becomes like a very costly endeavor for the asset owners. They have to not only buy a more complicated shutdown valve with all the controls and everything attached to it, but then there's a lot of costs associated just with the PM associated with stroking that valve and recording it and keeping up with it. Here's kind of some of our reference, some places we've provided the HIPS valves. If you're not familiar with HIPS, I believe it stands for High Integrity Pressure Protection System. We see a lot of this in the marine market, right? We don't always have like a big multi-stage flare system or space available to do that if you have like an overpressurized situation. So what people do instead is use a HIPS system where they'll put 2 of these valves in series, along with I think maybe like 3 pressure transducers in series. And if a certain pressures rise to a certain point, these valves have to close in less than a second and cut off the pressure supply to the rest of the system. Typically, it's been done with axial valves, which don't have as much capacity as like a full bore ball valve. It can get very expensive, and because of our low wear between the ball and the seat without any kind of sticking, we're really able to do that. So yeah, just kind of a quick rundown here on our valve again versus traditional ball valves. Right, we're cavity free, where no one else is. We offer bi-directional shutoff, where no one else does that. We test to 10 times industry standard in our cryogenic tests. We don't rely on any springs or process pressure to help us seal. There's no dynamic seals in our valve, just big static gaskets. We're torque seated, low wear, fully encapsulated seat. We're not going to leak through a thermal cycle. And then the big one is we have a very low risk of catastrophic failure compared to anybody else. Just a much, much safer, more reliable design. So that's kind of our base product in a nutshell. I got a couple other neat products I'd like to show you guys. And really these are born out of the fact that, we have like an entire engineering department that is very capable and very knowledgeable, and all of those engineers have been with us since day one. So one thing that I find about other ball valve manufacturers is that they have been around so long, and a lot of them have changed hands many, many times. And with that, they've lost a lot of their own tribal knowledge on their own product. For us, the guys that designed, valve number 1 and helped design it from the ground up are still with us. We did go through multiple revisions and small changes and improving our product as we go along. And so we have all, an immense amount of intimate knowledge and tribal knowledge on our own product, where I think a lot of others struggle with this. But also what that means is if you guys have a difficult application or something you would like us to take a look at, we have the ability to do that for you. And we've done that for a couple other customers, and this is where these next 2 products came from. The first is a double isolation and bleed valve. And what this is this is a ball valve with 2 bidirectional seats and a bleed port in between inside a single ANSI B1610 face-to-face valve. And so what this means is if you have a situation where you need verified shutoff, and so typically, people they hear about this and they think more towards something like a double block and bleed, but that terminology I feel like has been it's been very overused, and it doesn't really offer like what people think it does every time, right? What a double block and bleed is like a traditional showing you a ball valve with like single piston effect seats, where you're really just checking to see if one seat in one direction is sealing tight. What this valve does here is we have two bidirectional seats that are going to seal in each direction with a bleed port in between. So what you do is you close this valve and you can open the bleed port in between and verify that you have tight shut off. And then this creates a clean safety barrier so you can open up the pipe downstream. So people put this in a lot of places where they do know that they're going to have like maintenance, or they expect to have maintenance downstream, and they don't want to have to warm up their entire system or create a safety issue. Another place that it's used greatly is in like custody transfer or metering skids, where you have a meter we have to prove occasionally. And there's a few ways, and to kind of show you how this works and get into a little bit deeper, like this is the design here. And so really what it is, it's a single ball, and our seat has two soft seat inserts with a small bleed port in between, which is piped back here to a common outlet. And so what you do is you can shut this valve, and some people open that bleed port, and they test to see if there's any flow or pressure increasing there. Some people just pipe that right away to the flare. Others can open that bleed port and pump in an inert barrier in between of like nitrogen or something like that to create a safety barrier. But ultimately what you get here is you get, like I said, what's designed for is verified zero leakage, and it works extremely well. And traditionally, I think a lot of times this way this has been done, especially in cryogenics, is with two whole ball valves and a spool piece in between. And so when we get back to, we're talking about that space and weight savings, we're now doing this in a single ball valve body. It's a huge amount of space and weight savings when you come to designing your system. But also what it can mean is, like, say you already have an existing system and you've recognized a safety issue, you can go in and replace your existing ball valve with this without having to do any kind of piping changes. Does this make sense to anybody? Does anybody have any questions on this? I think you can I'm hoping these drawings here paint a pretty clear picture, right? We have these two bidirectional seats. This is the bleed, or this is the port, or the cavity in between that gets bled out at a common outlet here. All right, we'll move on to the next one. And this has been a pretty popular item on loading and unloading docks, places where you're going to have bi-directional flow, but at the time during the process you don't want bi-directional flow. So what we have here is a defeatable check valve. And what we mean by that is you have a check valve, like a swing check, that works normal as used, but if you want to, you can pull the swing check out of the flow path and then have reverse flow. Here's a little bit better drawing of it. So you can see here it's kind of like a gate valve body, but with a swing check down here. And so if you want, you have flow this direction, preventing reverse flow. But let's say this is like a loading and unloading dock, and one day you're loading the vessel, the next day you need to unload a vessel. What you can do is you put two of these in series, opposite directions of each other. You can open this one, close the other. And now what you've done is you have a single pipe run out to where the loading and unloading is happening, saving a whole lot of money. And you're able to maintain, without any kind of major changes, the flow direction that you need for the process that you're running that day. It's pretty simple, but like I said, it brings a lot of value. It can really reduce costs when you come to designing a system, and it's very reliable. But here you go. You can kind of see now, this is the check pulled out of the flow stream here. So, in the flow stream, out of the flow stream. And so that, like I was talking about, we have a full engineering department. We're here to kind of bring some solutions. We consider ourselves technical experts, not only in the manufacturing but also the design of these valves. And so if you have difficult applications, a difficult solution you're looking for, please bring it to us. We'll be happy to look into it. A couple other things I'll just hint on as we kind of wrap up here. Quality is a big issue for us. We focus a lot on it. A couple things that we do differently with our valves is we don't hydro test them. We do our shell and seat test with dry nitrogen and we drop the valve in a bath of water and look for bubbles. It's a much more reliable way of doing it. You can do a hydro test perfectly, and sometimes it's just not enough time to find a problem with a pinhole or something in a casting. This is a much more reliable way to do it. It's a little bit dangerous. This is why most people do not do it. You can see here, like in our factory, we've built these big cement bunkers. There's this big hydraulic cage that comes over when we do the test to keep everybody safe. And then we watch it with cameras and mirrors. Another couple of different things that we do is also we do dye penetrant tests on every single casting. We do X-rays on every single batch of castings, and everything is built to order. So that's one thing when it comes down to like also dealing with the ship classification companies. It's very simple for us. We have a lot of experience with them, and since we're building stuff to order anyway, it's very easy to track that order, have them come to the foundry and the factory and do their audit and get through it seamlessly. But we feel like we're ideal partners for these kind of applications. We know it's difficult for a lot of people out there to find good engineered solutions for cryogenic valves. We all cryogenic test on site. We can do fusion emission tests, particle tests, anything like that. But that's kind of it in a nutshell. If anybody has any more questions, please let me know. I'll be happy to address them now. Otherwise, Rick is available and the other Moody team. They know how to get a hold of me and share my contact information. But all of our our U.S. marine market is handled by Moody, and we'll be happy to work with any of you. Any questions from everybody? All right. I do know the presentation is recorded, and they'll be available at Moody's website. If you have any questions, please reach out. We'll be happy to help you. Thanks for your time. Our valve's a little bit different. It takes presentations like this to really gain an understanding on it.
Yeah, Bryan, thank you so much for that great presentation today. And like Bryan said, if you have any questions or need any more information, you can get in touch with me at rkoenig, Moody.com, or at sales@jamoody.com, or go to our website and you can find any salesman in your particular area. And if you want to schedule an in-house presentation, we can do that. Just contact any of us and we'll set everything up. And we appreciate everybody that showed up today. And thank you very much, Bryan, again.
Thank you.
All right. Have a great day, everybody, and thank you for joining us.